Good. Awesome. All right, guys. So welcome to the Brisbane Azure user group. If you're not here for Azure, may not be the right place. But if you are, welcome. So this is July, hopefully. Before we get going, really want to put a big thank you out to our sponsors. So without these guys, this wouldn't be possible. So, oh. Hang on, technical difficulties. Well, machine. Is that on this end?
Yeah. Oh, we have to share.
Help.
That one?
That's it.
Awesome. All right, so apologies for that. So if you're looking at the video later on, it's not my fault. I got this T-shirt that says, in my defense, I was left unsupervised, so I'm just going to use that one. So anyway, big thank you out to our sponsors. So Codify are awesome. They're great partners around Azure. If you're interested, hit them up. They're awesome. And Microsoft, thank you very much for the room. So Codify the pizzas and beers and all that sort of stuff. So thank you. It's a bit of a community event, so we really encourage lots and lots of people to get involved. It doesn't matter what it is. We just want to hear about your experiences with Azure or hear about some of the cool stuff that you're doing. Either or, it doesn't really matter. We've definitely got a spot free in August, and there's a few later on in the year. So if you have something that you want to share, let us know. We'd love to hear from you. And you can get involved with the community. It doesn't have to be a full session. You know, it can be half an hour. That's totally fine. So just get involved. An email there. So job opportunities. I'm going to hand this over to Dan.
So if you're looking for a new adventure and you have any of those skills on this slide, we're certainly interested in hearing from you. And although the slide hasn't been updated, obviously AI, that's a big area. So if you've got skills in that too, we certainly very interested in it. Yeah.
Awesome.
And if you want an indication of the quality of the people you get to work with, I'll present you tonight from Deloitte. So there you go.
No pressure. That's totally fine. Awesome. So updates. So a few things have happened this month. There's been a few more, but these are just like a small. It's been fairly quiet, but there's been a couple of little tiny things that have happened this month. So we've got a new WAF rule set, DRS. We've got a few things around that. We've got application gateway firewall logs protection. That's coming in preview as well. So it's about scrubbing data and all that sort of stuff. OpenAI service on your own data. So I'm going to just throw his name in. So I was working with Lee Simpson. I don't know if Dan knows him. So Lee was busy doing exactly this about 6 months ago. He was doing a great job, but now Microsoft's just copied the industry, and I think it's pretty easy to use. So you can now hook up GPT-4 with a whole bunch of your files, and you're able to use some of those large language models to interrogate your data. Works really good if you've got a very large dispersed set of data. If you've got highly structured data, potentially still go your traditional path and use the traditional way, but easy option. Elasticsearch, there's a few improvements coming. So I noticed there that it's coming to Australia East, so I sort of highlighted that one out there for you guys. So that is the expanded regional availability that I care about. So there's actually a lot more, but that's the one I care about. So multi-session connectivity, native integration with container storage, which is pretty cool. So Azure NetApp files have got double encryption that you can now use. So encrypted at the hardware level and also at the Azure level on top of that. So, you know, it's definitely an option for super secure at rest storage encryption for those people that are really focused on that. Pretty good. AKS network observability add-on. So this is around the nodes. Sorry, the pods. I use node pods anyway. Between nodes, the network connectivity, get a little bit more visibility into what's going on there. You know, networking issues or anything like that. This one here will allow you to have that greater visibility into what's going on. Cosmos to Data Explorer Synapse link. So this was in preview. I think we talked about it a long time ago, early this year. So it's now coming into GA. Near real-time analytics on your Cosmos data, and super low latency. So that gives you that visibility into your data and allows you to look at it in very fast time. Caveat: streaming ingestion. So, you know, a few updates for Go. So there's a whole bunch of SDKs that are now supporting a bunch of Go consumption of the Azure services. So Event Hubs, Blob Storage, Queue Storage SDKs have dropped for Go. So if you're a Go programmer, that's now an option. There's a bunch more HPC VMs. You know, they were already crazy speeds. Now they're even bigger. So is anyone using HPC stuff? I ask this question all the time because I want somebody to say, yes, I'm using HPC, but alas, no. Virtual network encryption. So this is an encryption at the network layer. It's using the NIC hardware to actually perform the encryption, and that's why there's only a few of those machines that you can actually use for this network connectivity encryption. But if you are after that higher level of encryption between VMs, this is a great option. But you are constrained to that set there of VMs. Event Hubs to Azure Monitor Logs. So if you've got log analytics, and everyone I'm sure is using log analytics these days, well, now you've got the ability to push from Event Hubs directly into your log. So it's pretty cool. And then from log analytics, you can do whatever you're normally doing with your analytics. All right. So if you're, sorry, apologies, no events. A couple of resources that are just going to flag. So we've got a Slack team, we've got a YouTube channel, so this will be up there. We've got some training things that we sort of like flag up, and a couple of cool blogs that are really cool to have a look at. My favorite is Scott's blog. It's really good. All right, so without any further ado, I'm going to introduce you Rachel. So Rachel is going to discuss private DNS infrastructure and supporting hybrid Azure scenarios, and I'm going to make way and let you take over. I'll move my drink before I spill that.
And then the cookie, will that act as Bluetooth to my computer? Or
It's not Bluetooth. It's a plug-in USB thing. Yeah.
Oh, I don't have a USB on this thing. Doesn't matter. I'll just.
All right, so welcome, Rachel.
Cool.
That one there?
Yeah, perfect. Thank you.
And you'll just need to share your screen, Rachel.
Yes. Sorry.
Like my laptop. It's hard to share.
Oh, and share.
That looks good.
Cool. Awesome. Cool. Well, yes. So, hey everyone. My name is Rachel. I probably should have kept that other slide on to give a bit of a background of what I'm going to talk about today and who I am. But yeah, as Dan had mentioned, I work at Deloitte, and I've probably been in the industry not that long. I came straight out of uni, jumped into my gig at Deloitte. Ever since then, I've been on Azure and implementation gigs and was quite technical. So I think that's about 4.5 years all up. So definitely still junior, still new, still learning. But what I'm going to speak about today is private DNS infrastructure support in hybrid Azure scenarios. So throughout my experience, I started on the enterprise landing zone. So, touched in hub spoke topologies, the networking, how you do connect to on-prem, how you connect spoke to spoke, Azure policy, all that enterprise level landing zone. As my most recent gig, I was kind of standing up a application level landing zone. So looking at APIM, we had a workload team to actually create the API. I don't do that. We set up APIM, network lock that. We still need connectivity to on-prem services. So how do we do that with private resolution? So our whole architecture was focused around a private network. So not having any of your services by default public. So how do you do that when you start thinking about private endpoints? Resolution to on-prem, how do you kind of architect that when you start thinking about custom domains? So you have an API via your organization's domain that you want accessible internal network as well as public. So how do you extend your DNS into Azure that's already set up part of your kind of on-prem systems? So I found a little quote online. I actually kind of amended it a little bit because we're talking about private network. But DNS is the phone book of the internet, in my edition, and your private network. So when we talk about DNS, domain name resolution, it's really about pointing a IP address to like a user-friendly name. Hence the phone book analogy, a phone number to a person. So it's kind of simplifying from a user end, something that's human-friendly, human readable, I think the term is, sorry, without you having to translate and remember, clunky IPs all the time. So that's what DNS offers. It offers it in a public setting, so google.com, blah, 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 any of your like public browsers, URLs, as well as internal network. So your organizations, we have to be connected to a VPN to potentially access one of your websites or potentially access an API. DNS pretty much replicates what they do for public, and they can do it privately as well. There's some additional configuration that comes from that. It's not as simple as a public DNS, where you kind of get into that network layer. But I'll describe that, hopefully simplify it through some diagrams that I'll show later with some scenarios. Cool. So when we talk about Azure DNS and DNS in Azure, there are three scenarios. And I'm talking about public and private broadly on the slide. So to the right, because our focus is in regards to private DNS in this presentation. To the right here, sorry, to the left, I always get my left and rights wrong, always. To my left here, we're talking about private DNS. So in Azure, private DNS comes through kind of like two different terms. Private link zone, so when you're looking at, you have a resource I was speaking about before, by default, that resource is publicly accessible. So it might be a key vault or it might be a storage account. It's not private by default. To make it private, you have to network lock that resource and you have to give it a private endpoint. A private endpoint is pretty much saying, hi, I need a space in my private network so that on-prem systems, other resources in my network can see me, can pull data from me, can reach me. So that's what a private endpoint does. And how that integrates with Azure Private DNS is Microsoft, or Azure, have kind of own a bunch of private DNS zones that are used globally across not only your organization, across other organizations, other tenancies. And that's what I call like the private link domain. So anything with prefix private link dot something something, they're all published by Microsoft. You can find them online. Those are the private DNS zones that support private endpoints. So it works very similar to how any other DNS does. On that resource, it's pretty much like a table saying this private IP points to this name. So that's how it's giving it a space within the network. Without a private endpoint configured private link DNS zones, you wouldn't be able to have you wouldn't have the DNS resolution flat. So we're not talking about on-prem yet, we're talking about Azure to Azure, just you wouldn't be able to have private resolution to that service. Now, another version of private DNS is custom private DNS zone. And I'm going to, no one can count how many times I say private in this presentation. So sorry about that. So another version of this is custom private DNS zones. So I spoke about the ones that Microsoft publish, anything with private link, they enable private endpoints. But there's also a version that it offers where you can create, as the name suggests, a custom domain name. It can be maybe an extension of your current root domain. So you might have organized org.edu.au. You're a workload team coming in with a large, enterprise data hub. You want to be able to have your APIs communicated via its own custom domain name. So you might have something like workload.org.edu.au. So you're an extension of, the term is like a subdomain of your root domain. So Azure gives you that ability to do so. There's obviously some configuration that happens as a subdomain. You have to say, hi, I want to be a part of your root domain, and there's some records that need to be exchanged. And that's kind of more at a DNS administrator role. That would help you set up that connection. But once you do have that connection established, you are saying, I'm a part, so I'm certified of this root domain, I'm an extension of it, and any of my records that I add to this can be seen from a DNS level, can communicate with other records on that root domain, or that anyone has a line of sight to that root domain. So for an example, we have one of our clients example, they have, like I was talking about, an API management service. They have APIs that are publicly accessible and privately accessible. So for their publicly accessible APIs, they use the public DNS. For their private accessible APIs, they want these APIs to be accessible via custom domain. So they have that, they are leveraging that subdomain DNS zone, and then they can create their APIs forward on, rather than leveraging what Microsoft provide you. They give you a default private domain name, but you can add custom if you like. You can obviously use whatever they have, but if you want, just it looks cleaner, sleeker, looks like it's really part of your organization's larger product. So that's private DNS, the two services that are really common, and you'll see throughout my scenarios, my flows, how they're used, and typically, where they may live within your network architecture. And then the middle one, which is probably a big focus of today, is DNS Private Resolver. Now, I don't have the time and date that it was released, but I would say in the last 2 years, year and a half.
I think it was GA probably without the last 6 months.
Okay,
But
well, yes.
Probably a little around about a year.
Yeah, okay, cool. So as you can tell, it's quite fresh. It's quite new. So DNS Private Resolver is going to be a focus of this session. And then this is really the service it's a PaaS service that helps you extend your on-prem DNS infrastructure, which you currently have, into Azure, meaning your Azure resources can privately resolve on-prem services. Your on-prem services can privately resolve Azure private services. So without that, right now you're just getting Azure to Azure resolution. Incorporating DNS Private Resolver, it's a bunch of obviously configuration that we'll talk about. You then do get Azure to Azure as well, but you can also get Azure to on-prem, or potentially Azure to another cloud network like platform, AWS, GCP, wherever you might have your other DNS infrastructure set up. So that's a really cool service in private DNS as a whole. And just to touch on public DNS, like I mentioned, it works the exact same way as private DNS, but it's for any of those publicly accessible records. So if you have an API, like I mentioned, that is both public and private, you would need records in both the public and private DNS zone, because depending on where your client or your user is coming from, entering your network, they will be directed to a different IP. If they're inside the network, they'll be directed to the private IP. If they're outside the network, internet, they will be coming in at a public IP. There'll be other mechanisms in front of that public IP that will secure it. But that's how in the two scenarios that you can incorporate both. But still, yes, still get public and private IPs together.
Split DNS.
Split, yes. Thanks. Cool. So next slide. So talking about how to extend your on-prem DNS into Azure. So for probably the longest time that I have been working, which isn't that long, have been around, IaaS was a supported solution. So really high level architecture here. But in the center here, you can see we have virtual machines. So as we know, IaaS is a bit more operational management. You have to worry about the OS, you have to worry about the patching. But in a sense, you absolutely could have that solution. You could absolutely extend your on-prem DNS into Azure, or your, like I said, AWS DNS into Azure, wherever it may live, through these virtual machines. And what it is a conditional forwarder, which is set up to say if you have, your custom domain that we're talking about, something like integration.org.edu.au, all of those records are managed and accessible inside Azure. You need a DNS forwarder that says, flip that around. If you're coming inside Azure, on your on-prem on the side, you would have pretty much a record that says that. Anything that has the suffix integ.org.edu.au directed to the IP of these two Azure DNS virtual machines. Then it will then forward it and do its thing within Azure to resolve your IPs. On the flip side of that, that's coming into Azure, on-prem to Azure. The flip side of that, going from Azure to on-prem or outside, you as well would have conditional forwarding rules set up to do the same thing, saying anything that is, let's say, on-prem.org.edu.au, direct it to the DNS servers that exist on-prem via port 53, which is the DNS protocol, and it will be able to resolve those records on those DNS servers on-prem. So you have forwarding rules setting up going to whichever DNS server kind of manages those records or that domain name.
So do you mean you need to set up zone transfer to the Azure private DNS zone from your on-prem?
Sorry, say that again.
You need to set up a zone transfer to the Azure DNS resolvers.
Yeah, so the on-prem DNS, that's just for a custom example, like the integ.org.edu.au, just say that's a custom domain that's managed in Azure. But for any of those private links that we speak about, the enable private endpoints, you would have to create the same name. So a kind of forwarding rule to say anything that has a suffix private link dot blah 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 directed to the DNS servers inside Azure.
Yeah, but Azure is just the resolver. So the DNS origin, the source of authority is still on-prem.
You have a delegation, don't you? You set up the delegation
Sure.
to the
So Rachel's talking about, so in this case here, for like integ, that would be a subdomain. So it would actually have full authority for anything integ. And so that would be where the conditional forward is used, basically to transfer. Okay, if you care about integ, then go to these ones in Azure. If you care about everything else, go back on premises.
So that's for a subzone that's going to host it.
Yeah.
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 Okay.
Yeah, sorry, thanks, that lingo was missing, going over me. Yeah, thank you. So that is a supported solution, and to this day, it absolutely works. It still works, but what that means is, you have to manage virtual machines. Like we said, 6 months ago, GA, there was a PaaS supported solution, which is the DNS private resolver that I was talking about before. It works very similar, but inside here you have a couple of different configurations. So inbound endpoints and outbound endpoints, and I'll talk about them on the next slide a little bit more. But obviously the benefit of PaaS, as we know, IaaS versus PaaS, fully managed, it's a bit more scalable. They did say cost reduction, which can be arguable because private DNS, in terms of operating, yes, but in terms of cost of the actual service, can be debatable because you can have multiple private endpoints, so multiple inbound endpoints or multiple outbound endpoints. Depends how your whole network architecture is currently configured today. But definitely operating costs, as we know with anything PaaS, it's you get rid of all that OS layer. Cool. So skipping to the next slide, this is where a bit more of a readable diagram of what was on before. So I gotta stay here because I gotta click some things. So in the center here, this is what represents the actual Azure DNS private resolver. So this is the service for it. We did scale it out a bit because inside that service there are some other key attributes that make it up. One of those being the inbound subnet. So what it is, it's a dedicated subnet for any, as the name suggests, any incoming traffic for your DNS. The inbound subnet actually gets an inbound endpoint, and it is an IP. It's a private IP that, if we kind of switch over to the IaaS version, it's pretty much like the IP of the virtual machine, but it's the IP of the PaaS incoming, service. So just like if you are having DNS conditional forwarding, like we said about that complete authority, anything with integ.org.edu.au on the on-prem DNS server would have a record that's saying anything that has integ.org.edu.au go to the inbound endpoint, which is that IP, private IP of the Azure private resolver. Now, another key part of this architecture is the outbound subnet. So you don't actually get an IP for the outbound subnet, but it is a subnet that is delegated to DNS resolver itself. And one really key part of the outbound subnet is a concept called forwarding rule sets. So it is the same kind of functionality of that conditional forwarding rule, but this one is not even but, it's just this is attached to the outbound subnet. So because it's going out, where do I forward this DNS query to? And those forwarding rule sets is you telling that DNS resolver, if it is part of this domain org, on-prem.org.edu.au, go point it to these DNS servers. If it is another domain name that maybe is managed on another DNS server, you would then create another record to do that forwarding rule. And how it works, obviously, is if it has a larger domain name, it will try and match it to the one that it has the matched with. If not, it will move down to the next domain name forwarding set and try and make that DNS resolution there. So that's the core piece with the DNS private resolver. And just for concept as well, so I talk about this private DNS zones, I talk about this custom private DNS zone. So private DNS zones or anything in this box is that private link. So private endpoint, to enable private endpoint, we use the Microsoft published private DNS zones that has a suffix of private link, dot, blah, blah, blah. They can, from like a hub spoke topology, and I guess if it was architected, simplistic, centralized DNS approach, private DNS zone, private link, are not only used for your own scope and your own workload, they're used across the enterprise. So you're another team in the organization, might also be using private endpoint. So where does it make sense for them to live? It makes sense for them to live inside the hub or the connectivity subscription because it's a shared DNS service. So hence why they live within there. You absolutely can still leverage those zones if you do not, if your resources don't live in that virtual network, because private DNS zones aren't deployed into a private network. They have virtual network links that say, hey, I want my resources to accessible to which have a line of sight to this network to be able to be resolved, but by no means is it deployed into a virtual network. Again, so if you're following a centralized hub-spoke topology, the management of all of this is really simplistic in terms of virtual network links. Where do you link it to? You might have 100 spokes. You're following a hub spoke topology. You only have to make that one link to the hub because there's a line of sight, and therefore DNS is centralized. If you have an architecture that doesn't really follow hub and spoke, and it needs to be uplifted in a way, a bit more management is required in terms of those networking links to say, yes, I want a part of that, or yes, I want a part of that. But by no means will you be blocked by it. It just adds a little bit more complexity to your DNS approach. And the top one here is that integration integ.all.edu.au, and again, it's a private zone. Why I have identified it in the integration production subscription, this is just an example, is because we're talking about who has the authority to manage these records, where does that private DNS zone live, where do those records make sense to be managed, and it is within the integration production subscription, because no one outside of the integration workload will be looking to ever use this custom domain name. So it makes sense to be managed the records within your workload scope if it's custom to your workload. But again, by no means does it not mean it can't be in the connectivity subscription. It just depends how your organization would like to manage their DNS. If they don't really care how you have the records because you're a subdomain and they're giving you authority, that's fine. However, if they do want a bit more control, they absolutely can leave the connectivity, which is part of the hub, which is governed by the networking and DNS admins.
Is the public IP resolution for this is the integration production subscription? Is that resolved by the same private resolver, or is that by Azure Public Resolver?
Yeah, so public DNS isn't not by a private DNS resolver. It's by that public IP. So the 168 blah 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 Azure DNS IP is what it does. So actually, did I write it in this diagram? Oh no, I didn't. But where it can set the scene again, it's an integration managed zone. Therefore, it makes sense to live in the integration subscription. Again, it's not tied to any virtual network, so who really cares where it lives, wherever we want it to live. But in this scenario, the public doesn't have any kind of network configuration. It doesn't need to say, hi, I want to be part of your network. It's a public domain name system, so it kind of lives silo on its own.
So can I ask what the Azure DNS plays in this role as per this diagram? So I'm thinking that the resolver is geared to give you private name resolution to resources that are exposed to the internet. And Microsoft has done some magic of splitting up the DNS, what's typically a resolve function on the DNS server, they've split that off separately. So what would be the use case where 168.63.129.16 would be asked a question in this story? Is this for coming back to on-prem or what? That DNS is really a public DNS, Azure DNS server, so it would only resolve public DNSs, or it would have, it would resolve public.
That's right. It does both. So because we have these virtual private DNS zones here that are part of like custom zones or private link to actually, I'll show you the flow. So if we start from the bottom, because the flow will explain kind of how it all works together. So if we start at the bottom, we have an app service making a query to resolve, let's say, something on-prem. So it makes a query because our integration production virtual network has custom DNS servers configured on it to say any DNS queries point it to blah, blah, blah. The blah, blah, blah is the inbound endpoint of the private DNS resolver. And see these links in the green here? So that's actually really crucial because this is how the Azure DNS default is initiated. So when you use Azure Private DNS, it has a sequence of kind of if statements to say, can I resolve my DNS query by any of the private DNS zones that are linked to the DNS resolver? One, because it's going to stop network traffic going on-prem and checking everywhere all at once if it can be resolved still within Azure. And how it does that is, one, by these virtual network links, and 2 using Azure DNS, because that's their communication kind of protocol for any DNS. So it initiates that to make these links to see if the record is in any of these zones, so any of those zones. If that is true, then that's where it will end. You'll be able to resolve your DNS. If that is not true, the second option that it does is once it's checked those, it can't see any of them, it will then look at the forwarding rule sets. Those forwarding rule sets are attached to the outbound subnet. So if your DNS query or the record does match the forwarding rule set, it will use the outbound subnet to push the type option 3, push the the DNS query onto on-prem, find the record, and then push it back into the inbound subnet, and then therefore you'll be able to get the DNS query. So the Azure DNS on the top left is just used to initiate and help with any of the private DNS zones by private link or the potentially custom private DNS zone. It's not actually actively doing anything, but it's helping you initiate with the help of those virtual network links in the green lines to see if it can resolve it still within Azure first. If it can't, then it will move to your forwarding rule sets to do the rest.
Where do you resolve internet addresses, Google.com, whatever, something, Azure DNS through that?
No, so that's still, well, any, just say if you are, this is Google's organization, all of that will be through here. It uses the help of that with that, because that's a private DNS zone. So none of it's going via an express route, none of it's going via on-prem, none of it's going by virtual network peering. Public is kind of the more simplest version of DNS, I would say. And private is where you have a bit more complexity and you have virtual network links. You need to have a line of sight to ensure that DNS can have that resolution available. And that's really important for that as well. So you might have all of these virtual network links set up and you might have your DNS forwarding rule set. But if you don't have a line of sight to where your target, resource is, it's not going to work.
Why not say, I think you can host resort to the zones that you don't own, as long as they're in your private VNet.
You can play this.
Let's say if your VNet doesn't have access to the external DNS service, you can certainly the DNS service, right? With a private resolver.
So sorry, so you can spoof what?
I mean, so if you want to resolve Google onto your own server using Azure private resolver, I think you could.
You're smirking. You're like, I can do something tricky with that. To be honest, I can't answer that question, but
Yeah,
if you
should
had,
be able to.
Like the same
it's not-
thing, but you have split DNS for iNetwork you.
Yeah, so you should be able to, if you set up a private DNS resolver and forward it to your zone.
Yeah.
Yeah,
Yeah, even if you don't
Obviously,
know
it's not
the
gonna be.
authoritative service for that.
Yeah. that's right.
As long as that's the primary resolver.
But if you don't create every record in all of Google, then services will stop working.
It depends on how you configure the port, of course.
It's at the main level, not at the
Yeah.
URI parameter level. So if google.com/API will resolve the same as Google.com/Google Analytics, or whatever you want the analytics to work, but not the API, then it could be.
Yeah, you can look at black hole, that's right.
Yeah.
Yeah, I wouldn't suggest it.
I was going to say, I'm trying the safe option here.
Suggest it.
So the gentleman's question, so which one asked it, that external resolver. So I'm thinking then there's potential, like talking, say, Google Analytics, the app service there, it needs to do some analytics and it's got no way out, but the organization has a proxy exit point that concerns stuff like that. So the app service will Google.com, blah, 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 and presuming would then go to resolve. The resolver would see the rules that I haven't got a rule set for it, pass it on, fail back to DNS. DNS would resolve the IP, and then the app service would try to work out how to get out to that IP, I'm presuming.
Yeah, well, outbound with public, and I'm going to be honest, I probably haven't grasped that whole concept, but because that domain name is owned and managed, like it's a public free browser that you can use, that type of like domain resolution has already been established within Google's domain servers, right? And they're synced across. So outgoing, it probably will look to use Azure DNS with DNS, communication IP. Therefore, can go outside to the public.
Azure DNS will go to public.
It will do an iterable recursive query.
To public, yeah, that's my question.
Yeah, but not private DNS resolver. So when we get those.
Yeah,
No,
Yeah,
but if
no,
you're
that's
an
what they're saying.
application-
Yeah.
that's
Like
what
an
it's
application needs to resolve something in Google, like genuinely real Google.com.
Yeah.
Go through Azure DNS, that would go off to.
Yeah.
Internet root DNS and find Google's.
Yeah, exactly.
Yeah.
Yeah.
It kind of leaves our network.
The only exception to that was that if you specifically said, I don't want Azure DNS to go out directly and create a forwarding rule set for the back on premises or to some other
Yeah,
site.
you do it all.
Yeah.
So your conditional forward, well, the equivalent to.
Split behind these columns. You're talking about.
So where do those private DNS zones, as you've got DNS, probably the one I'm interested in is the integ.org.edu or perhaps pvt.edu. Where does that zone file exist? So things will look it up. Is it a mini DNS server service being run? How do you edit or update those particular files?
Yeah, so like in inside Azure, it's like a show, but it's really like a table entry. So you jump onto the DNS. There's a resource name. It's actually called integ.org.edu.au, like on your all resources list. You click on that. It's a private DNS resource, and on that, it is just a whole table list of all of your CNAME records, A records, yeah, whatever it may be. And that's how you go and edit it. So if you, you're still working on your API, there's no IP yet to resolve, you wouldn't have the record there. As soon as it is, you do create that record for it to be resolved privately. And yeah, you have full, control to edit it. And that is exactly why, because it's part of the integration, your workload, why it makes sense to live inside your own subscription, your workload subscription, because you have the authority to change it and however you want. Yeah, so that's why it lives there. But like I said, it can kind of live wherever you want, depending on how your network and DNS admins want to control that. They want to maybe all of the records for DNS come through them. Therefore, it might make sense to live in a connectivity subscription.
But you can import your zone file into the private resolver, and that will resolve the records to your liking.
Oh, that's right. I was just probably wanting to get a handle on the UI on how that gets
Yeah, probably.
in place, because the dilemma is if you've got not having a resolve function in that, if you have like a pvt private.integ.org, whatever a subdomain, in typical you'd have to have, and you've got a one level up domain, you've got subdomains, you'd have to hit your forwarding rule sets particularly well. Otherwise, if you hit integ.org.edu.au, if it's got no resolver capabilities, it would not do a recursive query for you to find the subdomain.
Oh, it depends on how you import. So if you import zone with the SOA entry, which specifies the parent domain and parent zone, it's probably forwarded to your private network.
Probably within the network. It's just that your network, it doesn't matter. I'm just looking at subdomains and delegations and whether those things can do, if the rule set's not for the initial resolver to go elsewhere, the hitting that DNS for the zone file, if it can't do a recursive query, or the fact that the start of authority, if it has a start of authority, will it come back to tell it to go somewhere else? I'm probably just trying to compare real DNS, the full-blown DNS to these forget it, I'll show you.
Your forwarding rule set is dependent on your requesting VNet. Is that what you're using your forwarding rule set for?
No, so the VNet DNS configuration for VNet just says where do all my DNS queries going to go, where they're going to be resolved to. You can point it, if you don't have DNS inside Azure, you can point it to On-Prem. but there's kind of balancing actors. If you point to your on-prem DNS servers, it's not extended into Azure. You're either saying I can resolve Azure to on-prem, but I can't resolve Azure to Azure. So it's a balancing act. So in this integration production virtual network, you say go to the inbound DNS private resolver. Sorry, I lost my train of thought. And then these folding rule sets are only for outgoing. So if it can't be, if the record doesn't exist here or here, you want to reach a domain that isn't part of either your private network zone that's linked to the hub here, or if it's not reachable by this one, you need a forwarding rule set to say any of those DNS queries for that particular domain name, go and send it to the DNS server that manages those queries. So the forwarding rule set isn't attached to
So you then need to collate all of your integ.org private DNS zones, because currently when you create one in a VNet, you'll get that private zone within your resource group.
So
Then you can get that same private zone in a different resource group, and they will only have their own records. So where are they collated?
So you're saying if someone was to create the same
Well,
DNS
not so,
zone or the
so much.
resource
The
group?
one we probably all use is your database.windows.net. You put a private endpoint onto database.windows.net. But even if you would have a test VNet and a prod VNet, possibly multiple prod VNets, depending on how your isolation is configured. So you will have multiple private endpoint database.windows.net. You have multiple of those private zones.
Yeah, no.
How?
Yeah. So
How does this simplify that? Because currently, what I do is instead of trying to collate all of them, I just take my database or private link and I put my private link into my DNS servers, and I've just got my own fake private link database.windows.net. I've got it for files, whatever blob, and then I collate my own list in there.
Yeah. So that's like that, and that is obviously possible. But we are talking about a scenario here where we have integration called to edu.au, and I want that to be my only team works on Azure, so they're not going to be able to jump into the DNS servers and have the authority to create records like maybe you do now. So the networking team manages DNS. My workload team, they're just like little fishes in the pond. They don't have access into the on-prem DNS servers to do that kind of workaround. These private DNS zones are not deployed into virtual networks. They are linked to a virtual network, and the virtual network is really key is that it's linked to the hub, and that's why a hub spoke topology is really important, because that gives you the ability to just make that one virtual network link to the hub, and because the hub has a line of sight to all of your spokes, that's how you're able to resolve between spoke to spoke, all different types of spokes. So rather than having to create a private link zone in one virtual network, another virtual network, another virtual network, you create it once, you link it to the hub, therefore the hub has a line of sight and it can do all that domain name resolution. Yes, any other questions? So that's really important, but so it does give you the ability, the services that we're using is same as private DNS resolver. It gives you the ability, if you have a network architecture with a hub spoke, to still leverage private DNS resolver, private DNS zone, to still gives you the ability to do that. But in terms of management, it does become a lot more complex. So leveraging a hub spoke topology, architecting in a way where all of it is linked and looking at the hub gives you, that line of sight to the other spokes. Spoke to spoke. I go to the other kind of slide, and I probably just looking at time. What time is it actually? Okay. Okay, cool. I think we kind of go into this while we were talking about what the resources anyway. So I'm probably going to skim over it because I think the flows are a bit more important, a bit more informative So the private DNS resolver configuration, that PAS service that we're talking about, like I mentioned, dedicated inbound, dedicated outbound subnet. The minimum is a /28. The maximum is a /24. Just to note. So you can have one or more inbound endpoints. Again, you can have one or more outbound endpoints. With the hub spoke topology, it makes having the need for another endpoint or the outbound endpoint isn't, quite needed. Unless you have a scenario where, like I said, you have DNS as well that exists in AWS. You have DNS servers on AWS. You need an inbound endpoint for that. Maybe based on your network isolation rules or your network traffic or your bandwidth requirements, you want the traffic wherever it's coming from managed. Therefore, you can have multiple inbound endpoints. In most cases, though, from what I've seen, how I've used it anyway, we don't have a need in the near future to expand and add more inbound endpoints. But again, this service is created in a way where it's not just going to force you. If you don't have hub spoke topology, you're screwed. It's not forcing you down that track. Ideally, it's a simplified version and architecture, yes, but it's still going to give you capabilities if you haven't quite got there yet to allow for your current network architecture to integrate with this service. That's why you can get one or more inbound endpoints or one or more outbound endpoints. To say if it's the best or not adds more complexity, absolutely, but it's still giving you that flexibility. If you want to use this great PaaS service rather than virtual machines, it's still going to give you that capability to do so. Now, when we leave our virtual network, how does it know where to go? By our DNS server configuration. So we say, yep, we want it to go to the private DNS resolver. Again, that's pretty standard. And then the outbound endpoint has this DNS forwarding rule set. So this is an example of what it looks like. Really quite simple. This is our domain name. And I wanted to point it to the two on-prem DNS servers that are able to resolve that particular domain name. Now, if I go to the next slide. So the DNS forwarding rule set, when we're talking about extending our...
Sorry, question.
Yep.
Yeah, just thoughts on.
Sure.
So with the on the inbound side, so it's /28, you get 10 IPs. Can you just say any of those 10 IPs you can nominate as your DNS service?
No, you can't nominate it. So it's just randomly selected to you. Usually if it's the first one out of like the ranks for your endpoint.
Okay, so
yeah.
We pick 4.
Yeah, exactly. That's why I picked 4. So if I was to delete it, recreate it, Azure might give me 5. Not too sure. Yeah, it's just randomly selected. Yeah, it assigns it for you.
You don't get all 10. You don't have 10 listeners there and IP addresses. Okay.
Yeah. Yeah. And again, if you add more inbound endpoints, it has to be on a dedicated subnet as well.
So while we're talking about that, typically in your DNS client configuration, you have 2 or more DNS servers IP addresses listed. What's the HA on this? Because this is in your landing zone pattern. It's in a connection subscription. Is there magic HA behind the scenes for the resolver?
I don't know the answer, but I believe that is so. So that's why you only get 1 IP, because you get the minimum 2 because it needs that scalability in case of the DNS request that's recommended. But I don't know the answer for sure, but I believe that's so, hence why you have to dedicate a subnet with a bunch of available IPs, and then it does their own kind of management behind the scenes. And I'm assuming that as well, because it's a PaaS service, like why, like, give or take. And it is.
Yeah, that's right.
Yeah.
Yeah, so .4 is really a load balancer. That's why I just picked the first one.
Okay.
Well, that makes
No.
sense.
Yeah.
Right.
Thank you. Cool. And yeah, lastly, before we go into the diagrams, this is just in regards to those forwarding rule sets in particular. So I showed you an example. It really is quite simple, the rule itself. What is a domain name, what servers are going to resolve it. And then what's also really important is virtual network links for those forwarding rule sets. So if you can remember the diagram, forwarding rule sets are attached to the outbound endpoint. So when I'm leaving, where is it going? It needs forwarding rules to tell you where it needs to go. Virtual network links is pretty much saying, I want my resources to be able to be forwarded, be able to forward to this domain as well. So it's really important, hence this whole hub spoke topology situation. If you have hub spoke, less management, it's central DNS approach, just link to your hub, it has a line of sight, blah, blah, blah. For non-hub spoke topology, it absolutely still lets you do that. But again, it's more complex management. You have to have virtual network links to all of your spokes or some of your spokes that aren't following the centralized DNS infrastructure. So, hub spoke topology, which most clients I've come across have that in a sense. It might not be absolutely polished, but they definitely have that. So that's a really common scenario. But again, this service doesn't just restrict you in a box. If you don't have hub spoke, then you're screwed. It gives you that flexibility to integrate into some of your legacy, network infrastructure to still get this capability. But like I said, more management. Cool. So I want to set, this is where I go into the scenarios and the flows. So I want to set the scene of this diagram that I'm even speaking about and the flows I'm going to be speaking about. So on the left, the organization on-prem network, it's an on-prem network. It's got a 10.120/16. In the middle here, it has an express route into the hub. That's not taboo. That's quite normal. Express route into the hub. Inside the hub, that's where we host our private DNS resolver. That has a really basic IP address at the top. I spoke about this. This is because enterprise is shared. Not only is it shared, not only do our enterprise integration subscription use this, so do other spokes, other workloads across your Azure tenancy. So therefore, they are considered a shared service. Virtual network peering, hub to spoke. Again, we have our private DNS zone and our public DNS zone. Our spoke network has a 10.10.10/24. Now, inside our spoke, we have private endpoints, we have key vaults, data lakes, data storage accounts, service bus, all different services that are not private by default. They are public by default, so you have to network lock them, and you do that through private endpoints. And then down the bottom, we just have another subnet for app subnet, and it's an API app. On the left, we have internal API clients. We also have our on-prem DNS servers and a source database as well. And important, like definitely mentioned, we have virtual network links to our private DNS zones. So it's centrally managed. It's really, really important. And then public DNS out of the picture. It's not part of this setting the scene here. It's important to show that it is part of the DNS infrastructure, but not in our private resolution. Cool. And a couple other direction links I'm going to show you on the next couple diagrams is the DNS traffic and the network traffic route. Again, they're different traffic. DNS gets layer 7 and network.
Do you have the red and blue arrows here? Because I see in the green.
No, I don't. No, you're not seeing things. I don't. It's going to be in my next couple. Yeah, so the very important. They're 2 different traffic. Yeah. Cool. So this is pretty much what we had before, but just restructured a little bit. Scenario number 1. So Azure to Azure. How does Azure DNS private resolver come into the mix? Why can't I see on-prem? Blah, blah, blah. So Azure to Azure, let's say we want down the very bottom, purple, app service needs to resolve service bus. So app service is injected into an app service environment, which is dedicated subnet. It is network locked, and our service bus is network locked as well, but it is only configured with a private endpoint. So what happens is we have, and the kind of arrows are important here, but it's kind of jumping the gun a little bit with the direction arrows. But API apps, the DNS traffic, what it does, it goes, oh, actually, that's incorrect. But the API app DNS traffic goes kind of outside its virtual network, and it will go by the hub. So just assume that's kind of one, get rid of that. It's one kind of line. Apologies. So it's attached to this virtual network. This virtual network, our spoke, has the custom domain configured to say point to my inbound IP, my inbound endpoint, sorry. So it will go, via the hub, and it will hit the inbound subnet. So the DNS query traffic, I'm just recapping what I'm saying, is forwarded to the DNS server that is configured on the virtual network, which is the inbound endpoint of the private DNS resolver. So it's hit the inbound subnet. Cool, what do I do with it then? This is when I take it out of the picture because it can cause kind of some confusion, but that Azure, even I was struggling to wrap my head around what that Azure DNS default is doing, but it's igniting kind of that resolution. So what's happening is because I'm wanting to connect to service bus with a private endpoint go via those private link dot blah 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 zones. So it is looking for a record that is inside the private DNS zone. Now it's not going by the outbound subnet, it's not touching the outbound subnet because it doesn't need to. It's still within Azure, it's not leaving the Azure network. So because we have a private link DNS zone that's connected to the hub, that is saying my records can be read by the private DNS resolver. So it's able to fetch the, make the query for service bus, org integ service bus Sydney prod 01, blah, 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 able to respond with the CNAME. Then it gives it that private link suffix because that's like Azure's kind of translation. And then it's able to then respond with your IP that exists inside this private link DNS zone. And it really is a table entry or table that says blah, 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 IP 10.10.10.2. So once it does that, the DNS can kind of see itself, hence these double direction kind of arrows. The DNS traffic is then goes, via the hub back to, and again, it should be back to the API app. So now the API app can resolve that service bus. Therefore, what's happening, you have the network traffic. So the network traffic is app service is now established a private connection to service bus. You can see the network traffic doesn't actually leave our Spoke virtual network. It's still within the virtual network, but the DNS query is going outside and leveraging that shared hub service. And that's why it's really important that these two traffic lines, DNS and network, are described and shown to be two different routes because they absolutely are. I'll let that sink a little. So remember how I was talking about Azure Private DNS Resolver, and there's a couple if statements. If it can resolve it within these private link zones that are linked to the hub, it will try to do that first. And for us, in fact, it's found a match. Therefore, it's able to push the DNS query and give it back to the API app. Therefore, the network it can make a connection. The alternative, right? If this is where scenarios come in, is it doesn't need to leave anywhere. It's able to complete its if statement at statement number 1 because it's found the match, and everything besides that is kind of chucked out the door.
So in this case, it can get the DNS from the private zone, right?
Yeah, absolutely. Yeah. So it's gone. It's needed to leverage the shared DNS infrastructure that this exists in the hub because we've directed our virtual network to say go to this private DNS resolver because that's responsible for all of our private DNS resolution. Because we have these links to our private link DNS zone that supports this private link service-bus.windows.net, we're able to find the query in that private zone and then pass kind of the DNS resolution back to whoever was asking. Therefore, this service can say, oh, this fancy user-friendly name that I'm trying to access actually does have an IP. Therefore, the network is able to establish that connection. If that record didn't, just say you forgot and you didn't configure in that private DNS zone, it would go through those stages of, is it here, is it here, is it here, it's not anywhere, not able to resolve because it can't find that private IP, so it can't make that network connection. Cool, so another scenario here is on-prem to Azure. Now this is, again, even also a little bit simple, but you can see I've added the on-prem organization at the top. So we have a client that wants to resolve the domain API.integ. This is just say, sorry, actually more setting the scene. You can't see it here, but I'll move this across. we have the right here. This is a scenario that I've spoken about a lot tonight. We have a APIM subnet. It's virtual. It's integrated into the virtual network, injected. Then we have app service environment, private network locked, again, injected into the network. We have app service plans, yada, yada, but in particular, these API apps. This isn't important in our scenario here, but this is a scenario where I was talking about we have public records that come in, someone coming from the public internet. We have an application gateway that's actually fronting our APIM service. So this does all the WAF. This is the public IP that represents any of these APIs, and does all of it, the back-end translation, pooling. I'm not going to get into that. But in this scenario, that's not important, but that's how we've enabled public records for DNS. So for us, we're inside the internal network. We are a client on the internal network. We're not on the internet, so we're not looking at public DNS in this scenario. So I have a client that wants to resolve API integ.org.edu.au/dummy API. So this is one of the APIs that are managed on the APIM, and the backend is a API app. So that's the, oh wait, sorry. Okay, there we go. Cool. So again, red versus the purple. Purple is the network that has had to be initiated, and we have our internal API clients. It's on the internal network. Therefore, by default, because that's on the on-prem internal network, they have their DNS servers configuration is to point to the on-prem DNS server. So internal clients are configured to use the on-prem DNS server. So it looks to that one. I'll move this down. Cool. So the on-prem DNS forwarding rule set does exist in fact. That's a scenario where we're saying integ.org.edu.au, all of those records can be managed. They're managed not by us, they're managed on another resolver. So we're saying we have a record on our DNS server that says for integ.org.edu.au, I want it to go to the private IP, which is the inbound IP of the private DNS resolver. So, and again, this is because it has a network line of sight. We have express route from our on-prem to connectivity. It has a network line of sight, so it can get there. It hits the inbound subnet. Once it hits the inbound subnet, there you go. Again, we're not looking at any forwarding rule sets yet. We're coming into Azure, so we're not going out, we're not leaving, so we don't need to worry about the outbound subnet. It hits the inbound subnet. Because we have these private virtual network links to say, hi, any of my records I want to be seen. So it's able to fetch the API integ.org.edu.au to be a private IP 10.10.10.8, which is the private IP of the APIM service, which is the gateway for the API. And it's able to go get that record, push it back. Therefore, that was really fast. Therefore, we are able to make the network traffic all the way down to either one, whether it's API app or function app. So client has now established a private connectivity because DNS resolution has been able to be completed. It's able to establish connection, and therefore the traffic is forwarded to the corresponding backend, whichever it may be.
So the on-prem forwarding rule, in case of a child domain, that would be a self-delegation.
Yes.
Sorry, I was.
So, or you could potentially host a completely different zone and just set the forwarding rule to, let's say, forward the traffic to that zone to Azure.
Yeah. So on your DNS servers on-prem, you need to set up a conditional forwarder to basically go. That's what was sort of being explained in terms of the inbound subnet. So it would go to that IP address, whatever's set up there.
Like if you access, for example, directly the private link to us.
We'll see the challenge, which Rachel said before, is that the private DNS zones don't have an IP address. So there's no way that something outside of Azure can communicate to a private DNS zone. So the challenge previously was that anything on-prem had no ability to see the private zones. The only way you could do that would be to deploy VMs in Azure, which then are in Azure, and then can talk to DNS, or deploy the private DNS resolver, right?
Right.
But yeah, previously there was no way for you to then create a private zone and then have on-premise to resolve it, right? Which
Yeah,
that's
well,
the
unless you
challenge.
delegate it, if it's
Well, you can't delegate it because there's nothing to forward it to. There's no IP address to talk to for DNS.
Oh, right.
Yeah.
And now we have the inbound subnet that's linked to.
Yes.
Yeah.
You'll have the
Yeah.
something.
Yeah, exactly. Cool. And the last scenario of the night is Azure to on-prem. So this is where we start to, which is in the diagram, so apologies. But we talk about those forwarding rule sets, the importance of those. So at the bottom, we have a data factory pipeline triggered to connect to a source database on-prem. Now, why it's down here, data factory works. Data factory is just the resource. Anything that does that self-hosted integration runtime or private runtime, it is hosted on a virtual machine. So the virtual machine is actually what's doing the work. The data factory is just like the front, the UI, I would say. But a pipeline has been triggered, and where that request actually is coming from is the self-hosted integration runtime. So, like we've done before, we have it uses central private DNS to resolve the DNS server configured on the Spoke virtual network. That happens to be the inbound IP of the private DNS resolver 10.0.0.0.4 that we've seen again and again. So what is here's the inbound subnet. What it's actually doing is it's trying to check, as we know, tries to check if it can resolve it through any of the virtual network links first. That domain isn't part of any of these, so no. Option number 2, it looks at the forwarding rule sets that are attached to the outbound subnet. So therefore, it can see a domain, it can see the domain name for the on-prem network, and it can see that there's a forwarding rule set there. You can see that that forwarding rule set says to go to these IPs in the on-prem environment. So yeah, the example here, we have a domain name as org.edu.au, and the destination IP and the port for that is a 10.120.10.99 port 53. So it sends it onto the on-prem DNS server. Oh, that's a little S, but the DNS query for db01.org.edu.au does in fact exist within that DNS server resolver, and the response gives the private IP of within the on-prem network. Again, it's like these two ways. So it leaves the DNS server, comes back through the express route, it's the on-prem subnet. Therefore, we are able to establish our network connectivity route. So we leave the self-hosted integration runtime, we go via the virtual network peering, we go via express route, hit the database. We don't go through the DNS server because it's network traffic, remember. You come back through the express route, through the peering, and yeah, you're able to connect. So that's Azure to on-prem. So in these other scenarios I showed before, right, the only real scenario where you need forwarding rule sets is anything that's exiting the Azure network. Azure to Azure, it's all within Azure. There's no need for forwarding rule sets, any of the outbound endpoints. For on-prem to Azure, you're coming in, so you're not going out. Again, there's no need for outbound subnet, outbound endpoint, forwarding rule sets configuration. But when you are exiting Azure to go somewhere else, whether that be on-prem, might be AWS DNS server, because that, you know, holds its own workload private DNS. It's not managed in the on-prem server. It goes out and it will go out through the outbound subnet. If there was a scenario where you have, you know, AWS managing data.org.edu.au, I know I made that up, there would be a forwarding rule set on the outbound subnet. It says for data.org.edu.au directed to the DNS servers that exist in AWS. I don't know if AWS has a PaaS service for this, or if it's still using virtual machines. Either way, it would be directed to your private endpoint in that AWS environment that does the DNS resolution. But again, it has to have that network line of sight. You can have all these fancy DNS configs set up, but without network line of sight, you're not going to get the resolution and a successful connection back. Cool, so that really kind of wraps up my scenario. And these are my learnings from this engagement. I'm definitely not an SME in this area. I definitely did learn a lot though from this, and it's definitely given me a foundational understanding of how private DNS resolver works. More importantly, how to implement it. I would say in more of a basic hub-spoke, clear direction network environment. If it gets a bit more complex, don't come running to me and ask me questions because I don't know. But these are my learnings. There's definitely a lot more to learn in this area. DNS is a beast in itself. So yeah, thank you for listening. And yeah, thanks for coming along. Hopefully, I don't know, you learned something here. So yeah, that was it.
Well done, Rachel. That was awesome. Very informative and a lot of discussion too, which is great.
Yes.
Great things about
I think Rachel's too young for that.
it. Might be. I haven't part of it yet.
Oh, I don't care. That's fine. I'll take it.
You being your first time in this group, you probably don't know yet, but we
No, I
certainly
don't.
appreciate our speakers and yes.
Oh,
so,
thanks.
we like
That's
that.
awesome. Thank you. Thanks, everyone.
Fantastic.
So anyway, next we'll get one of these too. So
That's right.
whoever-
Speaking of next, we've got next month. So as